Okay, this is another practice quiz on quiz 4.4, so this is actually the second one we're doing. And this is the problem. It's 600 cubic foot open, 600 cubic foot open, top rectangular tanks. Base has a length 5 times its width. If all 5 sides are made of the same material, find the length, width, and height of the tank that will use the least amount of material. All right, so let's take a look at this. Now, the 5/2 is a little bit different than what we've done. So we've done some that are twice its width, 3 times its width, etc. We can do those, but this makes it a little bit more interesting. So what I did was I have my sketch over here. Now, we do know that the volume is 600 cubic feet, and that's going to be the constraint. That's going to help us a little bit later manage this problem. But right now, we know that the length is 5/2 the width. Now, this is kind of like a ratio problem. Sometimes we have these ratio problems and we have fractions. Now we could just say that call the width x and the length 2.5 or 2.5 times x. But then we're going to have a lot of fractions to deal with, and sometimes that isn't so desirable. But we can avoid that by using this little ratio approach. If I divide both sides by w, I have L over w equals 5 over 2. Then if I multiply the top and the bottom by x, I can say that L can be 5x and w can be 2x. Now you can check this. The length is at 5/2 the width. And of course it's 5x, so it checks out. So this is a good way to designate our sides. So I'm going to call the width 2x and the length 5x. And then the height, we don't have another variable for that, so we're going to call this y, but we don't have a variable in terms of x, so we can call that y. We're going to be able to work this out because we have some data over here. Now what we want to minimize is the amount of material, so we want to minimize the surface area. And that's going to equal, now remember we're going to have the base, one base, plus 2 sides, and that's going to be front and back. And that's going to be different from the right and left because 2x is a dimension of the front and 5x is a dimension of the back. So plus 2 other sides, that's going to be the front and back. So those are the 5 sides. Now this is y, this is also y. Okay, so my base is going to be 2x by 5x. That's a rectangular base, so I can just write 2x times 5x. And then plus 2 times the front and the back. And the front and the back, these are just rectangles that are going to be 2x by y, so just 2x times y. Now the sides are going to be 5x by y. Those will be the dimension of the two right sides. So we got the front and the back and the right and the left sides. Okay. So we can say this is the base and this is the front and the back. And this is the left side and the right side. Okay? Maybe that makes it clear. So that's our surface area. Those would be the 5 pieces of material we're going to cut out, and we want to minimize that. Okay, so we can simplify this. 2x times 5x is 10x squared. 2 times 2 is 4, so we've got 4xy. And we've got 2 times 5 is 10xy, and then we can simplify that. And now this is what we want to minimize. So we're going to have to take the derivative of this, but we can't take the derivative of this in this state because it's in 2 unknowns. We have to have just one unknown. So this is where we're going to use our constraint. Now this is our primary equation. All this is the primary equation, but I can write this over here. This is the primary. Sometimes called the objective equation because that's what we want to take the derivative of, because we want to minimize this. Okay? And we have what we call up here our secondary equation. which would be based upon the volume, and we know the volume, which is 600. You can see it right over here, 600. Equals the volume, and that's going to be the length times the width times the height. So that's going to be 5x times 2x times y, and this is the volume, and this is my secondary equation, or my constraint. Or what we call the constraint. And now that's going to allow me to reduce this equation from two unknowns to one unknown. So we can simplify this. We have 600 equals, and that's going to be 10x squared. And then if I solve this for y, because I only have one y here and two x's, so it's going to be a lot easier to substitute for y. So I'll divide both sides. So I've got 600 over 10x squared equals y. And that implies that y equals, and I can reduce this to 60 over x squared. So there's my y, and that's my constraint. So what I'm going to do is I'm going to put this in. And now I can write surface area as a function of x. And that's going to equal 10x squared plus 14x times y, and what's y? 60 over x squared. And now again we've got our surface area as a function of x. Now we can simplify this a little bit more. And 14 times 60, well, we got 0, and 4 times 6 is 24. Carry a 2, 8, so we got 840 all over x squared. So now we're ready to take the derivative, so we get a prime. And that's going to equal, what's the derivative of 10x squared? 20x. And remember, we can think of this over here as 840 times 1 over x if we want. Okay, 840 times 1 over x. And what's the derivative of 1 over x? Negative 1 over x squared, so that's negative 1 over I'm sorry, I simplified this wrong. I made an error here, excuse me. You're probably noticing that, so pardon me. Did all this good work and then I make this silly error. X goes into x squared x times, pardon me. Looking off my notes, not what I wrote down, so pardon me. Because I worked this out in class already for some of my classes. All right, so this is just 840 over x because I did the multiplication, okay, 840, and then x goes into x squared x times, pardon me. So that's where I have my 1 over x. Okay, so the derivative of 1 over x again is negative 1 over x squared. And then I've got my 840 on the top. And there's your derivative. Okay? And now we're going to, find the derivative. Now we could do this mechanically or by hand if you want, but it's kind of a hassle, and we're still going to end up having to use a calculator because we're not going to get a nice even solution. So we might as well use our calculator from the get-go. So we're going to put this in y. So y1, and I'm going to put 20x minus parentheses 840 divided by x squared. So that's going to go into the calculator like that. And I run out a little bit. I'm running out short on time here, so I'm going to do the calculator portion on the next video. But take a look at the setup on this, and hopefully that makes sense. And this is a good application of kind of using this ratio technique to make your work a little bit easier. So don't forget to look at the next video to see how to work these numbers out using the calculator.